Two.
Okay, good. Good afternoon, everyone, and welcome to Cal EPA Speaker Series. My name is Jacques Franco. I'm with the Waste Board here at Sacramento Cal EPA Waste Management Board, and I'm also with the I'm within the Waste Board. I'm with the Climate Change and Conversion Technologies, or Technologies Group. Today we're sponsoring, co-sponsoring this event with SMUD. SMUD is Sacramento Municipal Utility District, for the benefit of those of you that are listening in. SMUD has been in the forefront of deployment of renewable energies for a long time, and we'd like to thank you, Kate, for making this happen. Our topic today is evaluation of conversion technologies for municipal solid waste management, and our speakers are Jim Bender and Susan Higgins from Alternative Resources, Inc., based in Massachusetts. If you're listening in to this webcast, we have approximately 45 people that have signed in to this webcast. For those of you that are in remote locations and you have questions, please email your questions to jfranco@ciwmb.ca.gov. Those questions will be addressed by our speakers at the end of this section. Our speakers' presentation will last approximately an hour and 15 minutes, and we will reserve questions at the end. We will have a 30-minute Q&A session. I'd like to provide a little background and context of why or how conversion technologies fit into the Waste Board's organics strategy. Last year, the board adopted several strategic directives related to the management of organic materials. Directive 6.1 sets a goal of reduction of 50% of organics going into the waste stream. Directive 8.5 requires the board to assist local decision makers in long-range planning to help develop the diversion infrastructure and to implement Directive 6.1. As Directive 6.1 is going to be implemented, this will require an increased number of facilities and different types of diversion facilities, and the board is directed to assist local government in that process. Finally, Directive 9.2 encourages alternative energy and biofuel development for materials in the waste stream. Increased energy and biofuel production could increase diversion from landfills and provide new markets for organic materials. If you're interested in this topic, I would encourage you to participate in the board's December 9th Organics Roadmap, which will be dealing with the implementation of this subject matter. If you like to keep informed, I would like to encourage you to please sign up for the board's Conversion Technologies mailing list. The sign-up sheet is in the back table. If you're listening in from a remote location, we would like to know how to sign up. Please send me an email. Again, my email is jfranco@ciwmb.ca.gov. We have placed a number of handouts and samples of very good material that's available through the public, that is posted in the public domain. They're all in the back table, not all, some of them, but they're some of them are listed in the handout you were given when you signed in. Links to some of these resources are also posted in today's event web link or web page. If you don't know how to get there, please send me an email. I want to finally, well, almost finally, I want to encourage everyone that has an interest in this topic to please go and visit our web page. Our web page is going through a process of upgrade, and we have posted a few very good documents recently. In March, under a contract with UC Davis, an excellent report was produced. It's called Current Anaerobic Digestion Technologies Used for the Treatment of MSW. This is an excellent document. It provides an overview of both the technology issues, emissions, environmental impacts. Rob, raise your hand. He's one of the authors, and he's available here if you have questions. He's with UC Davis Bio and Ag Engineering Department. We have also posted recently a guidance document that was produced by a legal department that describes how conversion technologies fit with the board's regulatory framework. I'm almost done. Also, we will be posting very soon a few additional documents that may be of interest to you. UC Davis has almost completed a survey of conversion technology vendors, and the results of that survey will be posted in our website. In addition, results of a number of projects that are being sponsored by the board will be posted at our CT, or Conversion Technology webpage. Finally, I have a public announcement on behalf of the Energy Commission. For those of you that are affiliated with jurisdictions or developers and are interested in the actual deployment of these projects, the Energy Commission will be announcing in only 2 weeks away from now a new program that is called the Renewable Energy Secure Communities Program. It's called RESCO. And under that program, up to $5 million in grants will be available to communities that have an interest in deploying demonstration or exploratory projects in integrated renewable energy programs. If you would like to get some information about that, you can either email me or you can call Valentino Tianco at 916-654-4664. Finally, a few housekeeping announcements very quickly. Please turn off your cell phones at this time. Restrooms are to the north of here and to the south in the second floor. And I will have to give you a scripted announcement regarding fire safety. Please look around and identify 2 exits closest to you. In the event of a fire alarm, we are required to evacuate this room immediately. Please take your valuables with you and do not use the elevators. With that, I would like to now ask my colleague Kathleen Aviv with SMUD to please introduce our speakers. Thank you.
Thanks very much. Well, Jacques told me that he thought having this event on a Monday might mean a tiny crowd, so I'm gratified that you have all proved him wrong. This is a great turnout. Thank you all for coming, and thanks to the Waste Board staff for helping to organize this and put it together. As Jacques mentioned, I work for the Sacramento Municipal Utility District, which is a publicly owned utility, electric utility governed by a publicly elected board of directors that serves Sacramento County and a little bit of Placer. And SMUD has an interest in conversion technology for a number of reasons. We have an aggressive renewable portfolio standard objective that was set by our board. We're on track to hit 23% of our energy supply coming from renewable sources by the year 2011, which is just around the corner. And the board is currently considering the next set of goals to get us to 2020. And they will likely be also a little more aggressive than is dictated by the state. We also, as a generator, are working within a capped sector under AB 32. And that means that the 3 million tons of CO2 equivalent that we emit every year is going to be coming down. And we are going to need all sorts of different ways of making that happen. The Biomass Program at SMUD was formed to help deal with problem wastes in the local environment, things like dairy manure with all sorts of water and air and odor quality problems. But the definition of problem is getting much bigger in the future, right? Organics going to landfill, as Jacques mentioned, and municipal solid waste being trucked over the Sierras. Those things weren't problems to some people in the past, and they are now. And the city of Sacramento, as an example, is working to address that. So we are looking to conversion technologies as one way of helping us expand our renewable portfolio and meet these aggressive targets and continue to be able to provide electricity to our customers at a reasonable rate. So with that, I would like to introduce Jim Bender and Sue Higgins of ARI. Jim is a principal at Alternative Resources Incorporated. He has 35 years of experience in solid waste, water, and wastewater infrastructure planning and development for public clients throughout the United States. One of the reasons that we have been interested in working with Jim and Sue is that they work for public clients. They don't work for any of the conversion technology suppliers. So we think that gives them a good measure of credibility and, and assistance in evaluating what some of these technologies can offer. He is directing or has directed evaluations of new and emerging solid waste technologies for New York City, LA County, the city and county of Santa Barbara, as well as SMUD. And is currently managing the planning, procurement, and development of the Regional Solid Waste Management Facility for Taunton, Massachusetts. And then I'd also like to introduce Sue Higgins. She is a senior project engineer and director of solid waste services at ARI. She has 21 years of experience in a broad range of solid waste management systems, including strategic planning, feasibility studies, design, permitting, procurement, contract negotiations, and operations monitoring. She is serving as the project manager for many of ARI's conversion technology projects, including projects for the County of LA, the City and County of Santa Barbara, and New York City. Sue gets it done, right? Project manager. All right, so with that, I'm going to turn it over to Jim. Thank you.
Okay, you can hear me okay with this? Hi, good afternoon. Again, I'm Jim Bender from Alternative Resources, and I'd like to thank Jacques and Kathleen for the opportunity to come here today and share with you some of our experiences in evaluating conversion technologies for different projects around the country, and kind of tell you where some of those projects are, and give you a sense of what some of the promise might be with those technologies, as well as some of the issues that still remain in seeing them utilized to a large extent in the U.S. So, are you going to move the slides forward, or? Okay, you're going to get into that. Well, while he's working on that, Kathleen, we're not that large of a group. We're principals in the firm that also do some of the work. So both Sue and I share in those responsibilities. Just use this here, right? Same thing. Yeah, okay. Thank you. Just briefly, so you know who we are from where we're coming from. Alternative Resources, as Kathleen mentioned, we're a consulting firm. We're located in the Boston area. We do work around the country. We have been practicing in the solid waste field as a company for about 25 years, looking at everything from assisting municipalities assess different alternatives for solid waste management, as well as to implement those systems that they're most interested in implementing. Probably of most interest, the conversion technology projects that we're working on now include work with the County of Los Angeles, not the city, the County of Los Angeles, the City and County of Santa Barbara, City of San Diego, SMUD, and then going back some toward the East Coast, New York City. CRRA stands for Connecticut Resource Recovery Authority, which is a solid waste authority that represents municipalities in Connecticut. Delaware Solid Waste Management Authority. And then on the very bottom, Taunton, Massachusetts, which is probably one of the more advanced projects in Massachusetts, in that it's just issued a formal RFP for a project to be built at their regional landfill. I'm going to start by introducing some of the technologies and how we address them in terms of how we categorize them when we're working with our clients, and take you through some of what we've learned in a general sense. And Sue is going to come on after I'm finished and speak specifically to the project work we've done in New York City for the County of Los Angeles and for the City and County of Santa Barbara. Obviously, there are conventional means for managing municipal solid waste, recycling, composting, traditional waste energy, landfill, transfer, and then we've listed the conversion technologies and the categories that we utilize to describe them. Thermal digestion being anaerobic digestion, which is our focus there, hydrolysis, chemical processing, and mechanical processing. And this slide just tries to describe in a general sense what we mean by those categories. So in the case, for example, of thermal conversion, we're looking at the application of heat to break down the waste and ultimately produce a synthesis gas, typically in a reduced oxygen environment or starved oxygen environment. And then the syngas can either be used as a material to make a fuel, or it can be combusted to make electricity. And typically the ash that's left over is vitrified, or it's a char, and that prevents leaching of metals if the vitrified material were used in an open environment. Digestion, aerobic and anaerobic. Our focus has been on anaerobic digestion, which essentially is digestion in again, with a lack of oxygen. And we have more interest in that than the aerobic digestion process when we're looking at mixed municipal waste, because essentially it produces a biogas and less quantity of compost material for which you need to find a market. Most of our discussion today is focused, by the way, on managing mixed municipal solid waste. We're not talking about food waste. We're not talking about green waste. We're talking about managing mixed municipal solid waste in this presentation. Hydrolysis process where you extract the cellulose that's in the waste, convert it typically in an acid hydrolysis process to a sugar. The sugar, in turn, can be fermented into ethanol or other products. And then there are various chemical and mechanical processing means for separation of the waste and production of materials. Just to give you an idea, and this is not an all-exclusive list, there are many companies that are active in this business now. And we've categorized those companies, again, in terms of the thermal category, the biological, chemical, hydrolysis, and other. This isn't meant to be an all-inclusive list, but it's the names that you'll see over and over again when you look at projects that are ongoing throughout the United States. Some of these technologies have commercial facilities operating overseas. Some of these technologies have pilot or demonstration facilities, some of which are operating in the U.S., some of which are operating overseas. Why are public clients, at least the public clients that we're working with, considering conversion technologies? They're looking for environmental benefits, including reduction in air emissions, and in particular greenhouse gas emissions. They're looking to find enhanced use of materials, which results in less waste, ultimately requiring landfilling. And they're looking for production of renewable products that have strong year-round markets, such as energy, electricity, gas, and fuels. This slide kind of is a compilation of work that we've done in the projects in New York, LA County, and a little bit in Santa Barbara. And it is an example of some of the companies that have reference facilities. Again, some of these are commercial facilities, such as the anaerobic digestion list are commercial facilities but operating overseas. The gasification facilities are a mix of some commercial facilities and some demonstration or pilot facilities operating overseas. And we've broken the thermal into 3 different types of gasification. Just gasification in general, pyrolysis, and plasma arc. We'll get into that a bit more later. So it's important to recognize there are operating facilities commercially overseas. There's always a question whether the waste that they're managing is exactly the same as the waste as you'd see in the United States or in California. There's always a question as to whether the standards are the same environmentally as you would see in the United States. But there are actual operating commercial facilities. And also overseas, price is not always as low as you see in the U.S. for processing waste. But they are operating. It kind of reminds me, I've been in this business since the late 70s, early 80s, and it kind of reminds me of a point in our history where we're looking now at introducing perhaps technologies that have evolved overseas into the U.S. And in the late 70s and in the early 80s, when waste energy technologies were first getting started in the U.S., it took some time to bring them in, and they came in, and then they developed, and there are 100 facilities or so operating now in the U.S. Perhaps we're at a similar point now when we're looking at conversion technology and bringing some of that technology into the U.S. One of the benefits, again, landfill diversion. If you, interesting slide, if you look at, again, the 2 categories, thermal and anaerobic digestion, typically the data that we have indicates that if you're looking at the amount of waste that you divert on a weight basis for the gasification processes, typically they're greater than 90% by weight. If you're interested in the biological process, anaerobic digestion, typically they're in the 65 to 80 or 85% by weight basis. So if your goal is solely diversion from landfill, then probably you'd have a greater interest in the thermal conversion technology. In terms of net energy production, net energy being the amount of electricity that would be available for sale. So you generate a certain amount of gross electricity per ton of waste at your facility. You use a certain amount of that electricity at the facility to operate your facility, and the net electric output being the amount of electricity that would be available for export and for sale. And these are the ranges of net electric output that we have been seeing from the data that we have. So anywhere on the gasification end, anywhere on, from about 400 kilowatt hours per ton. Then you see a very high number on plasma arc, which is 1,250, but I have to caution you on that because that number is associated with what is a blended fuel, if you will, that is a much higher heating value than typical municipal solid waste. So it's not really a fair comparison, if you will, on that slide. It's not that there's some magic in plasma arc that allows you to get that much more energy from the waste than some of the other gasification processes. And part of the difficulty in looking at this data is that obviously the data has been gathered from facilities that operate on different waste streams. And so it's difficult sometimes to make sure you have an apples-to-apples comparison. And this is one example where the higher heating value of that fuel obviously affects dramatically the net electric output. Anaerobic digestion, you see that the net electric output drops off considerably. And acid hydrolysis, obviously, ethanol process. But again, if here you're interested in renewable energy, the most efficient way of producing that from municipal waste, if you compare the thermal and anaerobic digestion processes, would be with the thermal processes. We're doing a project in Massachusetts for the city of Taunton, and actually a request for proposals was recently released there last spring, and companies are now in the process of preparing proposals for a facility which will be a conversion technology type facility. But one of the things that we did for the Secretary of Environmental Affairs was to try and compare some of the emissions data that we had on thermal conversion technologies to the actual emissions data from municipal waste incinerators that are operating in Massachusetts now. And municipal incineration in Massachusetts is very prevalent. Probably about half of the waste stream in Massachusetts goes through these 6 different incineration plants in the state. And typically what we found was that the oxygen emissions were up to 100 times, 2 orders of magnitude less. Mercury, about the same, or up to, in some cases, 10 times less. Nitrogen oxides, approximately the same, in some cases up to 10 times less. Depends on the particular thermal technology you're looking at. But that's what we're looking at. So that's when people look at potential for better environmental emissions, they begin to focus on some of these particular emissions. I wanted to spend a few minutes to kind of give you a sense of what's going on based on our knowledge in terms of public initiatives in the United States. This is important to take a look at because probably 5 years ago, there were a lot of major entities in the United States, New York City, City of LA, LA County, that were just getting engaged, the state here, just getting engaged and looking at conversion technology and doing evaluations of what might be available in terms of technology. Several of those projects now have gotten beyond the study phase and have moved to the next phase of implementation, where companies have been shortlisted and as qualified to respond to requests for qualifications or requests for proposals. Proposals in the case of the city of Los Angeles have been received. Offers in the case of the county of Los Angeles have been received and are being evaluated. So we're slowly moving beyond the study phase, if you will, into an implementation phase, or the early stages of implementation. This slide, I just focused on what we're aware of that's going on in California. LA County, the 5 offers were received by the county in August. Currently, those are under review, and the county is looking to make a selection and to negotiate a project in the first quarter of 2009. So their concept was to match a conversion technology facility with materials recycling facility or transfer station so that they could take the residuals from that recycling facility and run them through the conversion facility to further reduce the amount of waste that would go to landfill. Los Angeles is currently also in the process of proposal review, and they have been to visit a bunch of facilities, as the officials in Los Angeles County have. City and County of Santa Barbara has established a short list of companies and is in the process of preparing a request for proposal. They're looking to put a facility at their existing landfill, at the Higgins landfill, 600-700 ton per day facility, to essentially replace or reduce to the greatest extent the amount of waste that goes to that landfill. That RFP will be issued in the first quarter of 2009. Sacramento, as you heard earlier, is in the process of negotiation of a contract with the plasma system. San Jose started some effort. I'm not quite sure where they stand, to be honest with you. If there's someone from San Jose here today, perhaps they could help us out. Salinas Valley has received proposals for a conversion technology facility. My understanding is they've shortlisted 5, and actually next week they'll be in the process, this and next week in the process of interviewing companies for that process. Santa Cruz County, California was considering an offer for a demonstration facility from a plasma system. And from what I understand there, the county supervisors were to consider that at the October meeting, but that has been pushed back now to a November meeting because there are still some unanswered questions there and they're not quite comfortable yet with making that decision. This is where the company was going to come in and put a facility at county landfill and demonstrate the veracity of that technology at that landfill without cost to the county. As a plasma system as well. San Diego is in the process of finishing the first phases of a study to look at what technologies to put into their zero waste approach for the next 10, 20 years. Orange County, California is just beginning a process now to look at co-locating conversion technologies at landfills and is presently in the process of looking for a consultant to assist them in that process. Jumping outside of California for a moment, New York City, which started its first studies in this area in 2003, 2004, has advanced to the point now of a siting study for a demonstration facility. New York City demonstration facility is anything on the order of 300 to 1,000 tons per day because they generate so much waste. They hope to have a siting study complete within the year, and then they'll issue a request for qualifications and proposals for companies to come in and build that facility. They may build one anaerobic digestion facility and one thermal facility. They're in the process of considering that. St. Lucie County, Florida, as I understand, is in the process of trying to permit at this point a plasma system. And to the best of my knowledge, that has not gone through the permit process yet, or the permits have not yet been approved. That's for a plasma system that will be built at a landfill. And the last two, Delaware is essentially in the study phase. And we love New York, so unfortunately this got put on the slide twice. It wasn't meant to be. It's only one New York City study. But the sense in these two slides was just to give you an idea of the level of interest on the public side around the country. And we see that where there are high energy prices, and we see that where there's limited space for landfilling, and we see that where there's an environmental ethic that says, I want to do more with the waste. I want to recover more material. I want to reduce emissions. And perhaps I want to make a fuel. So the promise could be the next generation of solid waste management technology. It's not perfect, but it appears to have promise of offering advantages to the existing alternatives in terms of lower emission, reduction in the amount of waste that ultimately you would need to landfill, and it enhances the recovery of materials for beneficial use. Many of these facilities have pre-processing facilities in front of the conversion process. And it does provide an opportunity for a source of renewable energy. Some of the hurdles that we have seen, obviously, there isn't a commercial facility operating in the U.S. So public entities are somewhat reluctant to step out and be the first person that's going to invest either money or is going to invest their prestige in putting together a facility like this. So a lot of the effort seems to be focused on doing demonstration facilities at a smaller level, and as confidence is gained in the performance of those demonstration facilities, moving on to a larger scale application. We have found that there also at this point is some uncertainty on the regulatory side as to how these facilities should be permitted, what air emission regulations should apply in case of a thermal technology. Should they be treated like municipal waste combustors or not when you combust the gas from those facilities? On the solid waste side, how should the facility be categorized? Is it a recycling facility? Is it a thermal conversion facility? What regulations do we have in particular states that we'll use in the permitting process for those? And we find, particularly in the East, that there's not a category of technology or a category in the regulations that specifically fits these technologies right now. Also, there's some been some uncertainty in California as to how to define these technologies from a regulatory standpoint. It's also unclear on the East Coast as well as the West Coast as to whether these facilities should be eligible for diversion credits from landfilling, as well as whether they should be eligible for renewable energy credits. In Massachusetts, there was a new energy bill that was passed in July of this year, where they've created a new category of energy credits called alternative energy credits, specifically to address solid waste projects that couldn't find a home under the existing definition under energy law in Massachusetts. So they're establishing a portfolio standard for utilities in Massachusetts that will deal with alternative energy credits, and that will foster a market for value for sale of those credits. Also in Massachusetts, I mentioned there's the Northeast states through RGGI, the Regional Greenhouse Gas Initiative, held their first auction for CO2 emissions, and that was at the end of September of this year. And the value came in, I think, somewhere just slightly north of $3 a ton of CO2 emission, and they didn't have any problem auctioning or finding buyers. So qualification for renewable energy credit as well as alternative energy credit could be extremely important. And lastly, we find just a need for public education so that the people can recognize the difference between these technologies and the technologies that they're currently considering for management of municipal waste. So with that, I'm going to stop, and Sue Higgins is going to talk very specifically about the project initiatives in New York City and County of Los Angeles and in Santa Barbara. So.
Thank you, Jim. Good afternoon, everyone who's here with us today and who's listening in by telephone. It's a pleasure to be here this afternoon. As Jim mentioned, what I'm going to focus on are these three projects which have really delved in more detail into some of the specifics of these technologies and attempted to essentially get past some of the marketing hype and really work to move these technologies from the study phase into the implementation phase. Going the wrong way. New York City undertook a two-phase process. And I'll talk just briefly about New York because it is a little out of date at this point in time, but it is important to understand the steps that New York City took looking at these technologies. Phase one of their process was a broad search to see what was out there for technologies, to determine what their capabilities are, and to begin the process of comparing these technologies to conventional disposal alternatives. Through that study, what was found was that anaerobic digestion and thermal processing as categories of technologies were the most advanced and the most ready for consideration in this country, with hydrolysis being proven only on a pilot basis. I'm sorry, I keep going the wrong way. The findings of the phase one study showed that in some ways these technologies were advantageous to municipal waste combustion. In many ways they were comparable, and in some ways they were disadvantageous. Looking at this list, as Jim already mentioned, some of the advantageous elements of it are the emissions, the ability to divert the waste from landfill disposal, and the increased beneficial use of that waste, including the generation of renewable energy. Looking towards the disadvantages, really focused on the provenness of these technologies. The fact that the sponsors out there were not yet pulled together as a team and ready to develop these technologies as much as municipal waste combustors had been developed in this country. Moving into phase two, New York City wanted to take a look at the more advanced conversion technology categories to determine if a demonstration project is feasible and warranted for the city. New York looked at anaerobic digestion technologies, aeroecology, and waste recovery systems, the Valorga process, and it looked at several thermal processing technologies, including gasification, pyrolysis, and plasma gasification, which, as Jim mentioned earlier, are essentially the three individual types of thermal technologies. And it looked a little bit at hydrolysis, recognizing that while hydrolysis was had not yet moved to the commercial stage, there was one company, Masada Oxinol, which was preparing to commercialize the technology in New York State. The phase 2 study was an in-depth verification and validation of technical, environmental, and economic information from these companies. As I mentioned earlier, it was really the first and most in-depth attempt to get past that marketing hype, to begin to look at the mass and energy balances, to begin to understand what is going in and what is going out. Jim had mentioned earlier that there's a lot of inconsistencies in data out there. You need to really understand what's the type of waste that's being handled. When companies talk about energy generation and diversion potential, are they talking about waste as received at the door, or are they talking about feedstock as prepared going into the unit? So these were some of the things that we were looking at in New York City. From an economic standpoint, the city was looking at its future cost in the year 2014 when it envisioned a facility might be able to come online. And it looked at its projected export cost being on the order of $124 a ton at that point in time. So as we looked at the economics for these facilities, we looked at, could it compare advantageously to that? For anaerobic digestion, we looked at both with and without the sale of compost, because for anaerobic digestion technologies, that is one of the issues that needs to be addressed. Is there a long-term, large, stable market for the sale of that compost material, particularly in the Northeast area? And those prices range from $56 to $80 a ton with the sale of compost, and a much higher cost if that compost had to be disposed. Thermal processing, as many would expect, ran at a higher cost level. We also looked at public ownership versus private ownership and the difference in cost there. The important thing to remember about these cost numbers is, again, this study is dated. This was work data that was gathered in late 2005, early 2006 for a report that was completed in 2006 and released in 2007. So, you know, as we move forward in each of the different jurisdictions that undertakes a project begins to gather cost data, we have to keep a close eye on how good are these cost numbers. Jim had mentioned briefly the status of the New York City project. They are undergoing a siting study internally now based on the determination that a demonstration project would be warranted for the city. They do intend to procure development of this demonstration facility. The companies that participated in their phase 2 study would not be the only companies that would be considered moving forward. And that's important to understand, that as time goes by, some companies disappear from the scene while others increase their capabilities and pull their teams together and move up the ladder of capability. And they're looking to put a project online in the 2011 to 2015 timeframe. Los Angeles County is a little closer to home for all of you. I know you've heard recently from Kobe Sky, those who have listened before, to the status of this. But for those who haven't, just to bring you up to date, Los Angeles County, similar to New York City, undertook a 2-step process. Phase 1 was the preliminary screening, the widespread look to identify the technologies around at the time and begin the process of evaluating them and shortlisting them. Phase 2, which occurred in the 2006 to 2008 timeframe, was the more detailed evaluation of the qualifications of the companies looking to build these facilities, as well as the capabilities of the technologies. This outlines, as you look at the slide, the level of effort that the county put in to get to where it's at today. They issued a supplemental RFI. They evaluated responses, conducted interviews, toured the facilities worldwide, and issued a competitive request for offers to the companies that were shortlisted. And we'll look a little bit more at this as we go ahead. These are the companies that Los Angeles County considered as it began its phase 2 process. And it's segmented into 3 sections up here. Following the phase 1 report, there were 6 companies that were shortlisted. But again, because so much changes so quickly, there was a desire to take a closer look at the status of several of these companies. The first thing that LA County looked at was they took a second look at those that had passed the screening but were not recommended in phase 1. And they also took a look at new technology suppliers that were not previously evaluated, again, holding all of them to the same standard. This represents the 5 companies that ultimately were selected and chose to participate. 9 companies were actually selected to participate, and after issuance of the request for information, 4 of them withdrew from the process. Again, following that review and evaluation process, 4 companies were shortlisted, and they're shown here: 1 anaerobic digestion company and 3 thermal companies. Jim had mentioned that one of the unique features of Los Angeles County project was to consider the co-location of a conversion technology facility at an existing MRF or transfer station, in large part to take advantage of the synergies of that co-location and to further reduce the quantity of MRF residuals going to landfill disposal. This slide here represents the 4 MRFs that were shortlisted for consideration. In getting to that point of having 4 conversion technology suppliers and 4 MRFs, this outlines some of the key elements that the county looked at. Again, as I had mentioned earlier, we really needed to look at 3 main elements: the qualifications of the technology suppliers, together with the economics and the performance capabilities of the technologies. In January of 2008, LA County issued its request for offers. The status of this slide is actually a little bit outdated. Offers were submitted in August of 2008. 5 offers were received, which represents offers from all 4 shortlisted companies, one of them submitting 2 offers. Those offers are currently under evaluation by an evaluation committee established by Los Angeles County, and the details on those will not be publicly available until that process is complete. The next project of importance is the City and County of Santa Barbara. Santa Barbara actually started this process several years ago. They got to the point where they shortlisted several companies, and a project did not materialize at the time. What the City and County of Santa Barbara is looking to do is to divert waste from disposal at the Tejeguas landfill by placing a conversion technology facility at the landfill. The City and County are working collaboratively, and they started the process by establishing goals. The goals are common to what most jurisdictions look for: the diversion of waste from landfill disposal, environmental benefits that could be achieved, and the generation of green energy and marketable products. They also were looking for a project that would provide them financial feasibility and sustainability. And they were looking to achieve the benefits that Jim had described when he talked about the benefits and the hurdles. The process that Santa Barbara followed is, again, a very prescriptive, detailed process. They've been proceeding slowly to make sure, and methodically, to make sure that this project moves forward in a reasonable way. After identifying project goals and criteria, they identified conversion technology suppliers, issued a request for information, evaluated responses, and shortlisted companies. They are currently working on preparation of a request for proposals, which will be issued early next year. This identifies the companies, 25 companies that the City and County of Santa Barbara issued the request for information to. Again, it shows a preponderance of thermal processing companies, but anaerobic digestion, hydrolysis, and other types of technologies remain in that mix. And this was important to the City and County. They weren't entering this with preconceived notions of any particular kind of technology. They're open to all conversion technologies. Of those 25, 11 responses were received. And again, across the board of the types of technologies: anaerobic digestion, thermal processing, including gasification, pyrolysis, and plasma gasification, and another technology which is a mechanical processing technology. For those of you in the room, I know this is a difficult slide to view. The importance of it is that the process looked at the 11 responses against 11 criterion, and it looked to shortlist based on those criterion. 3 companies were unable to meet the minimum criterion that were established. And in all 3 cases, it was because of the inability to demonstrate the processing of municipal solid waste. The companies that were shortlisted are 2 anaerobic digestion companies, California Renewable Technologies, which is a partnership of CR&R and Arrow, EcoCorp, 5 thermal processing technologies, again spanning the plasma gasification, pyrolysis, and gasification technologies, and Herhoff, which is a mechanical separation technology. These are unranked, and they're listed alphabetically by type of technology. In going through the RFI process and shortlisting, the city and county were not looking to rank. They're going to let that take place in the proposal stage. When you looked at the table that was up there before that showed the checks and X's, that indicated the evaluation criteria and who passed the different criteria and who did not, these are the criteria in a little bit more detail. There were 11 criteria that were aligned with the 6 goals. So some of them had a little bit more detail added in there. They were looking first at the ability of a project that could process at least 100,000 tons per year to start with, but ultimately up to 220,000 tons per year, which would fully replace the quantity of waste currently going into the Tehiguis landfill. And it had to be able to do so on approximately 6 to 6.5 acres, which is the area that's currently designated at the landfill for a project. They were looking for a project that could operate over a 20-year period and be compatible with existing solid waste programs. They were looking for at least 60% diversion from landfill disposal. Now, we recognize that that number is low, and most of these technologies would be able to do much better than that, and we would hope to achieve much better than that. But for the purpose of shortlisting and looking at who we would move forward with, that was where the bar was set. For a tipping fee, they were looking to have less than a 10% impact on ratepayers. And the question was asked in the RFI stage, what did that mean? And based on the county calculations looking at their system-wide costs and the structure of their tip fee, it was determined to be a tipping fee of less than $100 per ton. They looked at the end markets, the products that would be produced in the markets for those products, environmental performance, demonstration of the technology. And finally, it looked very importantly at the project team and what the experience of that team was and their financial resources. The next steps for Santa Barbara, as we mentioned, they're currently preparing their request for proposals and look to release that early next year. As they move forward in the preparation of that RFP, they're very active in a lot of side activities that go with that. They're looking to do an updated waste characterization study for the waste that goes to the Tehiguis landfill. They're looking to gather geotechnical information on the area where the project would be built. And they're working very strongly with the local jurisdictions that might become part of this project. They're reaching out to the cities that use the landfill, which include Solvang and Buellton and Goleta, to find what their interest level is in this project and to educate them on these technologies and what this project might encompass. As they do that, they're holding public forums and educational seminars. They're meeting with environmental groups, and they've been doing this on an ongoing basis. So public outreach and education is a very important part and big part of the Santa Barbara project. Proposals will be evaluated in the 2009 timeframe, with negotiations following that, leading into design, construction, startup, and operations. With that, I will turn it back to Jim, who's going to go through some representative photos of these facilities, and then we'll be available to answer any questions that you have.
This is just going to be a quick slideshow to give you some sense of what some of these facilities look like. Many of these pictures we took when we traveled with the Los Angeles County officials to view these facilities. Others we took at other opportunities. This is an example of a thermal gasification plant in Chiba, Japan, which is sized at 330 tons per day, operating since 1999. I'm not going to go into this. That's a schematic of their process. This is not plasma system. This is an example of the plasma system, using the Westinghouse gasification system in Japan. And this has processed over time municipal waste and auto shredder. We understand now it's primarily focused on auto shredder waste. It started operating in 2003. This is an artist's rendition of Plasco, which is essentially a plasma system, and this was part of their proposal to the city of Los Angeles for a 200-ton per day facility. And I think the architect had a field day there when they came up with the look for that facility. So probably only in Los Angeles would you see a facility look like that processes waste. Plasco operates a demonstration facility now in Ottawa, Canada, and it's just really begun to process municipal waste there within the last year. But they also process what I would call a prepared fuel, in that they mix the municipal waste with other waste materials. They've used tires in the past. They've used plastics, high concentrated waste plastics in the past. And they manufacture, if you will, a very high heating value fuel. This is just a schematic of what a system would look like. This was what was proposed to as part of the New York City study for a plasma system, using, again, the Westinghouse setup. Shows a combined cycle system, more efficient system for capturing the heat value of the waste than just the conventional steam system. GEM was another gasifier. This was a demonstration facility in the UK. Operated for a few years, and they're presently building a facility for an industrial application now in Ohio, and I don't know yet how that's doing. It's a schematic of it. Right here in California, in Romaland, you have company IES, which has put together a pilot facility at the 50-ton per day municipal solid waste size. Been operating on and off since 2005. It's a pyrolysis unit. It's a very simple setup, not in an enclosed building. It's set up as a pilot demonstration type facility. And their intent was to gather intense data on air emissions to share with South Coast Air Quality Management District to demonstrate that they could meet all the conditions necessary to be permitted there for a commercial facility. A schematic of their process. Another gasification process, NTEC, which is used overseas in the UK and Europe, is also in Asia. They use a front-end separation system for materials. This was what they call a kinetic streamer to separate materials. This was in the UK. We visited that. They also, which is kind of interesting, at the back end of their process, for the plastic that they recover, will convert that plastic into oil. We didn't visit this facility. This facility is in North Korea. We didn't have an opportunity to visit it. This is just to show you the simplicity of a gasification system. This was the NTEC gasifier that was used at a hospital waste facility in Poland. But you can see a 25-ton per day, small-scale facility. Served that hospital, also served to take the hospital waste from other hospitals within the region, so it was a regional facility. And they simply gasify in that first chamber where you see the two people standing in front. And the gases are actually combusted in the chamber above. And then you have a steam heat recovery system that follows that, and typical air pollution control equipment. In Malaysia, they're operating a 67-ton per day gasifier on municipal solid waste. Switching over to some of the biological systems, we did have an opportunity to visit the Aero system, which is a wet processing system, which is outside of Tel Aviv in Israel. This is what they refer to as their demonstration facility. It's 110 tons per day on municipal waste. And for any of those who have visited Israel, they don't recycle to speak of in Israel on the home front. Very, very little. So when you have mixed municipal waste going to a facility like this, it's all essentially of what would be generated at the household. They shoehorned this facility into an existing transfer station next to a landfill because they were given that space. Hard to see in that, but what the trucks do is they come in, back up next to the, there's no tipping floor, they back up next to the entrance to this processing building. The waste is dumped directly into a water bath, which they use to separate the lights from the heavies. The liquid fraction is digested anaerobically. They're using the digestate or the compost from that process as a soil amendment material. They use the methane gas and run it through an engine and generate electricity. They have since moved on and have built a commercial facility, 300 ton per day facility outside of Sydney, Australia. I'll just run you through a few pictures of that. This was when it was under construction in 2007. You can just, as I scan through these, see how the facility comes together. The tanks are the digestion. The building in the back is the waste processing. And that's what it looks like. That's a 300 ton per day facility. It was commissioned on July 4th of this year. They're currently in startup mode, as we would refer to it in the U.S., and they should be in commercial operation. They see it in the first quarter of '09. Another picture of the same facility. Another. And you can see some of the engines in this picture. They're again capturing the gas here and combusting the gas to make electricity. Inside the building, it's part of on the left-hand side are the water vats, and then the light material comes up on the into the trommels. Just another picture of the same trommels when they were further complete. They basically press the digestate at the end to remove some of the liquid. Just another picture of the trommels when they were complete. Water in the water vat. This is just as they were getting into the startup mode. That's why everything was so clean. Picture of another process in the U.S. This is depolymerization, or what we categorize as a chemical process. They essentially are taking as a feedstock here turkey parts from a turkey processing plant. So if any of you, this is not where the free-range turkeys are running around. These are the butterball turkey farms that they have back in the East, where they process these turkeys in the millions, and the parts that need to be disposed, this facility was made to handle. And so essentially it produces oil products at the end. That facility has been operating for a few years. They were attempting to begin to get into the municipal waste business, but they haven't yet achieved that yet. And that concludes our slideshow. Thank you very much. Sue and I will be happy to take questions. Oh, Jeff?
side of it, how many people here want to pay $250 to $350 a ton for the municipal solid waste? True, there's 2% residue, but that's a big price to pay when the average price in California is in the 40s to 50s a ton.
I don't know how to respond to all of that. And quickly, we're not seeing $250 to $300 a ton in the studies that we do, Jeff. We're seeing numbers that are in the $100 a ton range, in some cases less. What we that might be, but that isn't the price that we're seeing projected to do facilities here in the U.S. or in California. We showed the slide in Massachusetts because there was a particular interest on the part of the Secretary of Environmental Affairs in Massachusetts to see where they should go in the future. As you know, in Massachusetts, there's an incineration ban. You cannot build a waste-to-energy plant in Massachusetts. That's state policy. They're looking now at conversion technology as a potential technology to take them beyond that stage. So they obviously were interested in comparison of emissions to the facilities operating in Massachusetts. But you have to be very careful, again, when you compare any data, because you need to know what the feedstock is. You need to know exactly how that facility is operating when you take that emissions data. And we hope to give that warning when we started this presentation. So.
And you're exactly right that you need to consider this on a project-specific basis. And not only do you need to look at the feedstock, but you need to look at the emissions control technology that's added to the back end of that, and look at even with a traditional waste-to-energy facility, you can add more technology to lower those emissions. So you need to look on a project-specific basis at as these move from the study phase into the actual procurement phase, where we're getting real offers that are outlining the technology they actually will put on and what the cost of that project will be with those technologies, to understand the emissions and the cost related to that.
Yeah, in all fairness, Solution 9 looks exactly like Stanislaus, except for the plasma system and the combustor that burns the gases afterwards is a boiler, dry scrubber, and baghouse. So it's no different than how Stanislaus is permitted in 1986. So they look the same, the Johnson emissions are the same. It's not 100 tons. So in all fairness, let's compare apples to apples.
Well, that's fine. We're also not looking at just plasma and when we speak of gasification, Jeff. Yes.
Going back to that exact question, in slide 10 that had all the comparisons, is the data that you compared available, the data behind that slide? Can we just see what conversion technologies you compared and what the emissions were from those technologies?
Yes, that data came from the submissions in New York City, as well as City and County of Los Angeles. And so any of that information that's public certainly would be available.
What I was actually referring to is the information on which you based slide 10. You generated that out of
The emissions, I think at the bottom of that slide 10, you saw the Massachusetts reference to the emissions data. In terms of the conversion technology emissions data, it came from the reports for New York City and the County of Los Angeles.
Hi, I've been working through these solid waste conversion technologies for 35 years. There we go. I've been working through solid waste conversion technologies for 35 years, and I think that there's just a generalized failure to appreciate how serious the problems are in bringing these things to commercial fruition. And the process you're developing, I think, is selecting for optimists and in a sense. and I think this is borne out by the fact that many things are proposed, but these factories, these kinds of processes don't come to fruition. And when I've looked through them, and we looked through 5 different processes for a major waste company, you come up against things that are simply, they're not acknowledged. And I think we should acknowledge what the problems are. And secondly, I think we should be comparing these against a standard of things that we have that work, one of which is combustion, and the second of which is I know the Japanese are throwing a lot of money at their conversion technologies, and you can take specialized waste and you can convert them, but what you have is mixed municipal waste, and you should probably compare that to things that we have like combustion and bioengineered landfills, which are looking okay and comparatively much less expensive and much more benign, actually, than the anaerobic digestion processes that are more processing intensive. And in other words, we have things that work, and we should look at those, and we should look very hard at our problems that we do have, and not ignore what they are. We've published on this, and I have papers here if you want to see them.
This is kind of an informational item for everybody here in the room. The California Biomass Collaborative is going to be sending out a letter requesting input on any permitting issues that have arisen in developing these kinds of facilities, biomass to energy facilities in California. We are concerned that our regulatory requirements may be more stringent than some other states and countries. So anybody who's involved in a project that kind of hits a roadblock related to permit requirements in California, if they would kind of go to the Biomass Collaborative website and provide information, that would be really wonderful, and they hopefully will get an opportunity to respond to that letter that's going out soon.
John Cups, independent consultant. Actually, I had a couple of questions. One on the slide where you provided the comparative costs. I don't recall what the number was, the number of the slide, but I was curious, or the projected tipping fee. I was curious as to whether or not you recall offhand what assumption was made about the price of the energy that you were presumably selling for that was in that projected tipping fee, because obviously there's a very significant relationship between the price that you can get for renewable energy versus what the tipping fee has to be. So
yeah, the two slides that probably showed the numbers were the New York City slide and the one for LA County. And in both cases, we were looking at electricity prices about 8 cents a kilowatt hour. We weren't counting on renewable energy credits or anything beyond that.
okay, yeah, no, that's an important qualification. The other question I had, I guess it was in the context of the criteria, and I don't know whether it was for LA or the Santa Barbara study, but it appeared like the criteria was the facility had demonstrated operation for, what was it, 6 months and 50 tons. And I guess my question, or maybe it's more of a comment, that strikes me as certainly not a very lengthy demonstration, and one that you're willing, that certainly I would never advise any of my municipal clients to bank on a technology that had that sort of minimal demonstration. It seems to me for a municipality to invest the time, energy, and resources to develop a project, that they would want something that had a real demonstrated track record of commercial performance before you would go down that path. And so I guess I was really kind of curious as to the thinking behind that 6 month and 50 ton criteria, because that's mind-boggling to me that a municipality would consider this type of investment, even just in terms of the resources to get to the point where you could make a decision based upon that short of demonstration period.
I think you're referring specifically to City and County of Santa Barbara, and it was, the criterion was 50 ton per day over a 6 month period, or and what wasn't actually shown on there, for facilities that operated on a pilot scale, so it operated intermittently, it was looking at 1,000 tons per day of MSW having been processed. That is actually not unlike what was considered in both the city and county of LA and even in New York City. And the concept there is that we're not at the stage of selecting a technology supplier to develop the project, but we're trying to open the door and look, considering a broad range of capabilities, the capabilities of the technology and the qualifications of the technology supplier, opening that door to bring in the ones that have that are the most likely to succeed, but yet recognizing some may score higher in some categories and others may have more experience or capabilities than others. When you get to the proposal stage, it is very important then to very seriously consider the level of demonstration that has actually taken place and get into that comparative mode of comparing and contrasting between the different technologies. And certainly those that have operated longer, have more facilities at a larger capacity, have demonstrated to a greater extent the technology.
And maybe to get to the part of your question on the investment on the part of the municipal side, both in the case of the County of LA project and the City and County of Santa Barbara project, both those entities are looking toward privately financed facilities so that the private entity will take the risk, if you will, for performance and payment of the debt service. And some municipalities aren't willing yet to jump to a commercial facility. LA County said, we'll do a demo facility first. And that's the path they're going down. They'll let the demo facility provide the evidence that they feel they need before they jump to larger commercial scale. Santa Barbara, the site sits right at the Higgins landfill. They're not so concerned about having a place for the waste to go if this facility doesn't work out of the box for them, because they've got some years of capacity left at the landfill. But in both of those cases, we're looking at privately financed facilities, so there isn't a municipal investment, if you will, other than there is an investment in the procurement process and there is an investment in selection and contract negotiation, yes, but not in the capital cost of that facility. I don't know where LA County is. We have not been involved in the whole part of LA County, nor the city of LA in terms of the total cost. I can tell you that the effort in Santa Barbara is considerably less than that, without going into numbers. But yes, there is a significant transaction cost. But at some point, someone looks at the potential benefit of these technologies, and maybe they're there and maybe they're not. We tried to point out that these facilities haven't been demonstrated in the U.S., okay? But somebody needs to look forward and say, if my goal is really to divert the maximum amount of waste I can from landfilling, to get maximum materials recovery, and to do something with the heat value in a positive way, whether it's electricity or combined heat and power, someone has to move forward. The comment I made, okay, if you looked at where this country was in the late 70s and the early 80s, first Arab oil embargo, there were no waste energy facilities in this country. There were incinerators. First waste energy facilities came into this country from Europe. And you know what? They didn't know how difficult it was going to be necessarily to get those to work in the U.S. marketplace. Private companies were willing to take the risk, finance those projects, several in the East, and they moved forward. Some of them are still operating today. Perhaps, I thought I made this comment, we're at that same stage in this country where we're looking at technologies potentially that could do better than what we have now. And yes, there's some risk in their application, but maybe it's time to take a risk if that public entity feels they're protected, either because it's privately financed or because it's a demonstration scale facility before they jump into commercial, or they have another alternative, at least for the time being. It's a tough situation.
Sorry, Fernando. Mark White again, Pacific Waste Consulting Group. You had one slide, I think it was slide number 9, maybe 8, that related to the energy output from the different technologies. And you mentioned that 1250 for plasma was a combination of, there it is, was a combination of tires probably or plastic and MSW. Again, kind of going back to my question about the emissions, because we don't necessarily, in fact, not necessarily, we do not have access to all the information in the LA reports. I would really be interested in this one also, seeing what's behind it, what's involved in the assumptions that get you to that middle column, so that one can better understand. I agree with you completely. We need to go somewhere with these technologies. If we're going to do something with greenhouse gas, better get the stuff out of the landfill. But for us to understand and be able to be as passionate about it as you, we need to both understand what's behind the electricity production, because obviously that's a good bit of your revenue, but also what's behind the emissions. And telling us to dig it out of all these reports from New York City and LA without having some distillation of those makes it much more difficult. Then I have one follow-up question on another slide after that.
Okay. The first point I want to make is, and I made this to some people before the meeting started, this range doesn't necessarily represent data input from every one of those technology suppliers that you saw on prior slides. This information is difficult to obtain, okay? Whether it's emissions information or whether it's information relative to performance on these facilities. So we have compiled that information through some pretty extensive processes in New York City and LA County. I think there's a good amount of that is available through those reports. We distilled it for the Secretary of Environmental Affairs in Massachusetts for that particular project application in Massachusetts. And there are actually some very specific tables that were submitted to the Secretary that also are a matter of public record. So perhaps if I get contact information from you after, we can certainly forward those to you. But it takes a while to get through all of that and make sure you're even close to having apples to apples. And Jeff doesn't think we have that yet, and maybe he's right.
I'd only like to be sure we all have fruit. My last question is that in the LA County slide, you had 4 MRF locations shown as potential project sites. Just an observation, maybe you can respond. It seemed like 3 of those were outside of LA County.
Yes, that's true. I'll respond to that. But that project was set up to promote conversion technology in Southern California, not just LA County. So I make that point.
Fernando Bertone from the Waste Board. Getting back to cost, in your analysis, did you look at the cost of these facilities versus, and then compared that to perhaps the avoided costs from long-term liability from landfilling? Because I'm not sure if one thing that's not factored into the equation is avoided costs from long-term liability for landfill maintenance, post-closure maintenance, et cetera. So when you're talking about X dollars per ton for a conversion facility, does that take into account the avoided liability costs at landfills?
No, no, it does not. When we put the analyses together, we were looking at the cost of construction of these facilities, financing of these facilities, operation and maintenance of these facilities, disposal of any residue, but we didn't look at avoided costs, if you will, of landfilling.
Aaron Sharma from Sempra Energy. You briefly talked about the diversion credits for some of these facilities. With the exception of anaerobic digestion, none of these thermal technologies actually qualify for diversion credits today. So are these cities working under the assumption that at some point in time in the near future that would be a reality?
Let me start, and maybe Sue can add to that. I think that I know from the standpoint of the county's working toward, hopefully, that goal. I don't know the city of Los Angeles. Okay, it's something that certainly, if it were available, would facilitate development of these thermal facilities. And if you're looking at, again, as the slide showed, if you're looking at maximizing diversion and maximizing the amount of energy production per ton of waste, then you don't want to necessarily throw out the thermal technologies. Philosophically, whether you give them diversion credit or not is a tough one. And some of those technologies on the thermal end probably wouldn't currently qualify in California.
I think at the beginning of today's session, Jacques had mentioned several publications that were available on the website. One of them was the legal document summary of how these technologies fit into the waste board structure, which is actually a good source of information to answer exactly that question. Some of these technologies, when you look at the thermals, particularly pyrolysis, our understanding is would absolutely not qualify under today's regulatory structure for diversion credits, but depending on the specifics of the technology and the facility that was ultimately constructed, some of the others might qualify. But that document is a good source of information for understanding some of the details that go behind that.
Thank you. I just have a follow-on question. Have you looked at the emission comparison between anaerobic digestion to energy versus some of these thermal technologies, and how do they compare, if you've seen any of that data?
We did that a little bit in the New York City Phase 2 report, which is available on the internet. And again, it comes down to the fundamental problem that getting at emissions data for these technologies in a common apples-to-apples basis is very difficult to do. Offhand, standing here today, I can't remember the specifics of how they compared, but in that report there is a section that addresses emissions, and there is a table that summarizes the various emissions from the different types of technologies in the specific companies compared to regulatory standards. So that's something I'd recommend you take a look at the New York City Phase 2 report.
That's available on the city's website as well.
If you want to look at that report, go to today's event website, and there's a link there. Who's next? Okay.
Cedar Kehoe. I'm with City of Elk Grove. 2 comments. First, you indicated the Westinghouse was originally doing municipal solid waste and auto shredder, but you thought it was only doing auto shredder now. I'd like just clarification on that. And then my big issue. With reference to the plasma arc technology, if you speak to them, generally speaking, they would like everything except for the metal and the glass, because that takes a lot of energy to convert it. So when you then have the conversation, okay, so what do you really want? And they said, we love all your cardboard. We love all your paper. I have real concerns about, okay, I'm not got my whole system to get all this cardboard and paper out, but they really want it. And all of a sudden there's this big financial issue. Where does the stuff like cardboard and paper go? Do you send it to where it gets burned? Or do you send it over to getting recycled? And the truth is the numbers on any of this are not out there. You're not, or at least I can't find anything that really shows, because in truth I think they would rather you not take it out of the waste stream, but that you send it to the burning units where they can get the electricity for that commodity. So that's kind of my question.
What was the question specifically, though?
The issue is the whole funding of this thing. If I take the paper, and I don't recycle it because these people want to really burn it because there's energy to it, how is that, quote, helping to divert resources to a better alternative use? I mean, I don't see it. To me, it's like, I'm not making more cardboard out of that.
No, I guess the position that a lot of these projects are taking, first of all, they're taking post-recycled municipal waste. They're not attempting to have you go back to the homeowner and say, don't recycle your paper and your cardboard and your plastic. Continue to do that. So when we looked at the waste composition for these studies, we looked at a post-recycled waste composition for these studies. Interestingly, you know, on the plasma, and if they can enhance the heating value of the feedstock, then it enhances the net electric output. But they could take industrial plastics, they could take tires and other waste that aren't in the normal household waste stream. But it's very important to look at the waste stream that you're going to use for that facility when you do your analysis. I agree with that. Several of the technologies also have front-end processing in which they have the ability to remove plastic and cardboard. Several of them have that ability to do that depending on what the market conditions for paper and cardboard are. and this is with anaerobic digestion as well as thermal. So if the market for paper is strong, or cardboard is strong, they'll remove it. They won't run it through the biological digestion process and make gas. They'll remove the paper and cardboard and sell it in the market, but they have that flexibility. So it's important to know the waste stream you're dealing with. I think Sue made that comment. I would reinforce that comment. And then I think it's important to think about the flexibility of the waste stream you can take as well. And I'm very concerned. There was a story on the news here over the weekend about scrap metal prices going south because the economy in China now is going south. And so somehow when you're looking at waste management, you need to look at a system also that's going to give you some stability on pricing. But these CT processes, the one in, the story on LA County that we're trying to say is it's co-located with the MRF to take the residuals from that MRF. Those residuals would have gone to a landfill otherwise. Instead, they'll run them through the MRF, further take whatever value is left in those residuals before the ultimate residual would go to a landfill.
Just to answer your first question, too, about the facility in Japan, the Westinghouse facility, our understanding is exactly what you stated. It was designed to accept either 165 tons per day of auto shredder residue or 300 tons per day of mixed municipal solid waste. There is very little public and published information on that facility, but from what we understand, they did at some point in time process MSW and do not process MSW or very little MSW at this point in time. It's the auto shredder residue and other types of waste mixed with that, not what you would recognize as a mixed municipal solid waste after recycling or a MRF residual.
I'm Stephen Valentino with Plasma Solution. I was curious to find out the net energy production of these various technologies is rather impressive. But in terms of the emissions that the different technologies produce, are there any that produce none? Are there any systems that are closed that do not produce gas emissions or particulate matters?
Yeah, you have to be really careful about this one because a lot of folks will say there are no emissions from my conversion process. But then what you need to consider is what are you going to do with the product from that conversion process? If your product from that conversion process is a synthetic gas, you're going to combust it on site and make electricity. There are obviously emissions from the combustion process to make electricity. If you're going to turn that synthesis gas into a fuel, there are ultimately going to be emissions when you put that fuel into a vehicle and you drive away. So I don't think there's any process that could claim that if you look from the beginning to the end in terms of use of that gas or the fuel that you make would have zero emissions because you're doing something with the gas that you generate or the fuel that you produce. And when you do that, there is some emission associated with that. I think you need to take into consideration.
We'll take a question from the web.
Okay, this is from Patrick Carter, Sonoma County Waste Management Agency. He's wondering if you have studied the trade-offs between aerobic and anaerobic digestion, specifically knowing about the nutrient value of anaerobically digested compost and whether that is similar to traditional windrow composted yard debris.
I think the focus of much of what we have done and much of what the people, the municipalities and jurisdictions that we are serving have looked for is that one of the key outputs of these processes are energy. And so we have not, the answer is we have not in the work we've done and been talking about today, done a lot to compare very specifically the aerobic and anaerobic process. Our focus has been on those that generate energy where the aerobic process does not generate that energy, it generates a compost product.
Do we have any additional questions from the floor? Okay, well, then I'd wish to thank very much Jim and Sue for making all the way to Sacramento without generating any greenhouse emissions, I'm sure. And thank you for participating.
Thank you. Thank you.